Hi, uh, can you imagine what would be the topic we're gonna discuss now? We have two pictures, right? Can you guess what would be? I'll give you 5 seconds. Yes, expect microcontroller addressing mode. Yep, today we're going to explore the addressing modes of big microcontroller, an essential concept in understanding how instructions access and manipulate the data. This is the foundation for writing efficient code and maximizing the power of embedded system. Are you ready to jump in? Let's get started. Addressing modes are the maps for finding operands. They specify how a microcontroller identifies the data it needs to execute the instructions. Imagine you are trying to find a book in the library. Do you look by title or author or by location? Similarly, addressing modes define how the microcontroller finds and work with its operands. By mastering this, you'll know exactly how to optimize operations in your embedded systems. Let's divide the five addressing modes of the PIC microcontroller. First, we have immediate addressing mode. Here the operand is directly specified in the instruction itself. Think of as a packing your lunch. Everything you need is already in the box. For example, move LVOX55 means moving the literal value of OX55 into the working register WIRG. Why is this useful? It's super fast because the data is directly available. Use it when you want to load a constant value to a register. Can you think a situation where this might be useful in your projects? Next up is it is register operand addressing mode, where the operand is stored in one of the CPU's register. It's like reaching your pocket to grab your wallet, quick and efficient. An example of add WF status WRG, which adds the value of WREG to the status register. This mode is perfect for operations involving internal register. It's quick because you are working within the CPU itself. Any guesses on what kind of calculation or operation might need this? Here we are moving to the memory operand addressing mode, where the operand is located in the addressing mode. Memory address specified directly in the instruction. It's like having a specific shell number in the library to find your book. For example, move the WF 0 cross 20 moves the value from WRAG to the memory location 0 cross 20. This is great when you need to access a specific memory location or register. What real world examples might require this precision memory handling? Next, direct addressing mode. The instructions uh, directly specify the memory address of the operand. Think of it having the exact address to deliver a package. No extra steps needed. For example, move WF cross 20 moves the value of WRAG to the memory location of 0 cross 20, making it a perfect accessing specific memory location quickly. Now let's talk about indirect addressing mode. This is where the address of the operand is stored in another register, such as file select register. Think of it as a treasure map. FSR, the location of the treasure data, and the instruction retrieves it. An example is MoveF, INDF, WRG, which uses the address in the FSR to access the data. This is useful for dynamic operations like accessing arrays or sequential data. How many of you have worked with arrays in programming? It's similar here. Finally, we have a bit addressable mode. which allows direct address to specific bits in a register or a memory location. Imagine turning a single light switch on off in a huge control panel. An example of BCF status 5, which declares the bit 5 of the status register. This mode is ideal for precise control in the application like setting or clearing flags in a status register. It's a lifesaver for managing individual bits in hardware level programming. To make the most of these addressing modes, it's crucial to understand the key register like working register, the workhouse for data manipulation. FSR is file select register used in indirect addressing to point the memory. INDF it is indirect file register access the data directly via FSR. Posting and postdic is allowing dynamic addressing with automatic increment and decrementing. These tools make addressing modes flexible and more powerful. Any question about these before we move on to the activity? All right, let's apply what we have learned. Here is an activity for you. I'll give you an instruction and a scenario, and you will define the addressing mode and this use case. Let's give a simple example. Move LW 0 cross 30, which is addressing mode of this. AWF status. WRG is what the mode we are using it. BCF status 2, which mode is at the play. Let's discussion your answer together and understand the reasoning. Please post answer in the comment box. Great that today we have uncovered the 5 addressing modes of the PIC microcontroller and how they work with operands. Mastering these modes will empower you to write the efficient and optimized code. Keep exploring and experimenting. The best way to learn is by doing. Thank you, and I look forward to seeing your creative application of this knowledge. Let us see how many of you are posting the comments in the chat box. Thank you.